Hi there everyone, and welcome back to the second recorded video for the Introduction to ArchiCAD resource. So what we did last time was we learnt what ArchiCAD is. We had a brief introduction to the types of courses that you'll be using ArchiCAD or other CAD programs in. We also walked through the basic functionality of ArchiCAD, what it's used for, as well as some of the basic concepts for it. Now, one thing that we didn't actually cover was that after you download an ArchiCAD file, there are multiple file types after you save your first ever project. So what we're actually going to do is we're going to extend out this type. Now, the standard ArchiCAD.pln file, that's the extension for it, is an ArchiCAD solo project. And if we make this a little bit bigger, you'll see that that is what the icon looks like. Now, after you open up an ArchiCAD file, you will generate a backup file. So it's an ArchiCAD solo project backup. Now this backup file is shown through essentially the visual of this arrow so that you can distinguish a project file from a backup file, as well as through the actual file type name, solo project backup. Never open up the backup file to start working in it. As you can actually see, this recent file from the 10th of the 11th has a different date and time from the backup file. That's because when you first start working on a file for the day, it will then update the backup file to that point in time. And there are automatic autosaves as well, although they may not necessarily apply to the backup file. So you always want to make sure that you save the file you're working in and that you then open up the same standard project file. So what we're going to do now is we're going to right click on the solo project file, open with ArchiCAD 24, or you'll double click on the file, or you'll open up the ArchiCAD 24, 25, 26, whichever one you're using, icon, and then pick it from the recent files list. So let's open this up. Now, just while this is loading up, what we did last time is we introduced you to the program itself, where to download the program, as well as what you first see when you open up the program, which is the work environment. We also discussed very briefly another important part of ArchiCAD, which are story levels. Story levels are height references in relation to sea level, and those height references are essentially particular heights based on your site. So we've now opened up ArchiCAD. What we did last time is we looked at the introduction, we looked at how to pan around. So if we push down the middle mouse button, which you'll be able to see down at the bottom left in the overlay, it lets you pan left and right. You can zoom in and out, or you can use the arrow keys. So always look down at this overlay when you see me doing something, because then you'll see what I'm actually pressing. So we went through all of this, we explored what the work environment was, we explored very basic terms what stories are, the height references in relation to sea level. It's the height of the specific point on your site, a site being a location. What we're going to be talking about today is one of the most important and arguably one of the most complex parts to understand of ArchiCAD when you first start using the program: layers. Now before we start, as mentioned last time, there will always be a link down the bottom here that you can left click, right click copy, and paste it into your browser, and this will bring up a user guide help page from Graphisoft themselves to help you understand more about what we're actually looking at. In this case, layers. So, what are layers? Well, if we remember from last lesson, we have something called views. Now, views are where we take an original from the project map, we save it with a specific name, and we apply some settings to it. Those settings define what type of drawing you're creating, and one of the actual main things when you're doing that definition of what type of drawing you're going to be creating, that one of the main settings is something called a layer or a layer combination. So it's very, very important to understand this even at a most basic level. Now, layers define individual elements. Now, an element is a term that you're going to be hearing quite often when it's got anything to do with ArchiCAD, because an element is a drawn item, whether it's a line, a fill, a wall, a door, a slab. All of those are elements, and we define elements by assigning it to a specific layer. Now, this gives it an identity which determines which drawings or views that element will turn up in. For instance, if we assign a wall, an external wall layer, that means in any views that should see an external wall, it will appear. And we'll get more into how that actually works soon. But in, say, a site analysis or a survey, now a survey is essentially a drawing that shows the context, the contours and the heights of an existing site. So you could say that if we weren't showing this building here, or this proposed slab, and it was just the existing site, which is this building and all of these contours, that would be a survey. Now we would not see any proposed external walls in a survey, meaning that layer does not belong to that type of drawing. Now, not all elements should show up in every type of drawing that you create, as some elements will not be relevant. We've just explained this, but let's go into a little bit more depth with a few more explanations. In an electrical layout of the house, should we be seeing the electrical layout of a house when we're looking at a section view? Now, a section is a cut through the building at a certain point, looking in a certain direction, and you'll see the construction of it. Now, since this is a section, we should not be seeing an electrical layout, because we're not going to see the lights or the wires or anything like that. So anything in an electrical layout, the layer that we assign that to, should not be visible in a saved view of a section, because the layer or layer combination is different. Now, when we're looking at a site plan, that's actually what this one is. A site plan should not be confused with a site analysis or a survey. A survey, as we've just explored, is the existing context of a site and the contours. A site analysis is an analysis of that existing context, which will help us make informed decisions. So you'll see neighbouring dwellings, the shadows that they project, you'll see these heights, the fall of the site, views to and from the site. You'll see any directions that noise could actually be, because you need to do an analysis of all of the surrounds. And all of these different bits of information helps us make informed decisions when we design something. So that is what a site analysis is. A site plan should not be confused with that, because a site plan is the finished site. We've done our design, we're showing our design in context of the existing surrounds and the rest of the existing site. It's essentially a bird's eye view after construction has been completed. So as you can see, we see the roof, we see information related to the building, as well as the proposed driveway, in amongst the rest of the context. Now, since the roof is in the way, we're not going to see any kitchen cabinetry. So that means that the layer that kitchen cabinetry is assigned to is irrelevant to a site plan. So that layer should not be activated in a site plan. Now, should we see the proposed design of a house when we're looking at a survey or site analysis? Well, we just covered this. The answer is no, because a survey and site analysis is the existing context. The proposed design of a house is the drawn-in proposed elements that we actually design. They're not related, so it should not be seen. Now, just because an element has an individual layer doesn't mean it should only ever show up on one drawing. For instance, if we look at this over here, in this site plan, we can see the roof. In this section, we can see the roof. That means that that roof is assigned a layer for the roof itself, so it's essentially a roof layer. If we click on this, you'll actually see roof-general right here. Now, even though that layer is the same layer for both of them, it appears in two different drawings. That is because just because an element has an individual layer does not mean it should only ever show up in one drawing. It will show up on any drawings where a roof should be seen. If you are doing, let's say, a footing plan, so the footings are essentially the construction elements which help make sure that this slab and this building and all of these built elements actually stay where they are. It provides the foundation for the building. Now, these footings shouldn't really be seen in a roof plan or a site plan. But this roof, likewise, should not be seen in a footing layout or a slab layout plan. So that means that specific layers are specific to certain drawings, and specific elements and layers can show up on multiple drawings. Now, exterior and interior walls would show up on countless drawings, such as floor plans, electrical plans, floor finish plans, and setup plans, but walls will not show up in a surveyor site analysis, like we've just explored. Now, another way to understand layers, just very briefly before we go forward, because there's actually some thought exercises ahead, and you can actually see it over here as well, is that if we assign an individual layer per element, then what's a way that we can visualize this without actually reading something? Well, let's think of Photoshop, for instance. Let's say that the original piece that we bring in, let's say we're editing a photo, the original piece might be likened to the original from the project map. A view is a take on that original. We are adding specific things to it to change what it looks like. So let's say the original photograph is just that of a landscape. Now let's say that landscape, we essentially assign a view to it, we save a view to that landscape, and we want to filter things in and out. So we want to bring in a little cabin and put it into the actual picture. We also want to bring in some people. So the cabin will be one layer, the people will be another. We're bringing in all these different elements. We're bringing in shadows, we're bringing in people, we're bringing in pets, we're bringing in cars. Each of those are assigned a different layer. Now, each of those layers will come together in a combination and it creates a specific drawing. That drawing will be a view. But now let's say we wanted to do a different rendition of that original. So we remove all of those elements, but we might keep the cabin. But let's say it's a different type of cabin. This one's a rundown one. Maybe some of the trees have actually been destroyed or cut down. So that different view portrays a different set of information, a different drawing. So each view represents a different take on the original photograph. I guess if you know AutoCAD as well, then those will make sense to you, because that actually does happen in that. If it's Revit, then it might be similar to families, I guess. I'm not too familiar with Revit, so if I'm wrong, then I do apologize. Now let's look at the next important part, which is completely and utterly linked to layers. They are one and the same, which is a layer combination. If individual layers are how we identify individual elements, then how does ArchiCAD know which layers should be showing and which ones should not? So if we have one drawing and another drawing, so two separate drawings, how does ArchiCAD kind of differentiate what should be showing on one, what should be showing on another? It's a layer combination. A layer combination is a combination of individual layers to achieve a certain type of drawing. Now, something that we did explore earlier is that you can have an unlimited amount of views per original. Each view will have its own settings. Each of these settings may be slightly different, and each of these views will have a different layer combination. The layer combination essentially is the drawing itself. Now, a good way to visualize layers is through imagining the old overhead projector at school. For some of you that are younger, this may not really be relevant, but back in school we had overhead projectors with these see-through sleeves. You'd pop the sleeve onto the projector and it would project an image or a part of an image or some text onto a board or onto a projected screen. Now, let's say that one sleeve represents one piece of information. You put on another sleeve and it adds more information into it. Put on another sleeve and it adds more and more and more. So each sleeve represents a single layer. Multiple sleeves together represent a layer combination, and that layer combination represents a drawing. Now, as an example, let's use this over here, since it's something visual. The roof represents a single layer. The driveway is another layer. The contour lines would be another one. The boundaries would be another layer. Each of these represents a single sleeve. When we put all of that together, what it does is it gives us a drawing. But let's say that we took out some of those sleeves and we put in some different ones. Let's say it's a different option of design. The filtering in and out of those individual sleeves is what defines the differences between each layer combination. Now let's use a different example. Let's say that you're drawing a face. The outline of the face is one layer. It's a single sleeve. The eyeballs are another, the nose is another layer, the mouth is another, the eyebrows are another, and the hair is another layer. All of those individual layers come together to create an image, a drawing, a painting, a face. Now let's say that we wanted to try something a little bit different. We take away the eyes, the nose and the mouth, and we put in a different version of them. So we've filtered some of those sleeves out, put some new ones in, and it's created a whole new drawing. So that would be a whole new layer combination. Now let's have a look at another example. This one's a bit more straightforward. If we refer here, each sleeve has different information. So this is pretty much what we've just done. I'm just showing you something more visual, more concrete. Sleeve 1 represents external walls of a building. Sleeve 2 represents internal walls of a building. And sleeve 3 has some furniture. Each of these are different layers. We put them all together and we get a floor plan. So external walls, internal walls, and some furniture for a kitchen and a bathroom. So what we've done now is we've combined individual layers to create a layer combination. Now here's another example. It's a bit of a bigger one. And it actually relates back to the site that we're looking at over to the left. Layer 1 or sleeve 1 is site context. Site context is defined as the information related to the site and the surrounds. So boundaries, contours, trees, street, and neighbouring buildings. Now the second sleeve and layer is a sun path diagram. So sun path diagrams are part of something called a site analysis. Now we explained this very briefly before. A site analysis is an analysis of the existing site to inform our design decisions. The sun path diagram is one individual part of that type of drawing. So this is our second layer. Now the third layer, that's the existing building on the site. When we put all of that together, we get a sun study layer combination, because the drawing that we have is a sun study. Now let's remove the sun path diagram, so let's turn off that layer. We're left with this. It's an incomplete drawing. And what we're going to do is we're going to add the layer for the driveway and the layer for the roof. When we add those layers together, we get a site plan layer combination. So if you remember back to what we were discussing before, this is exactly that. The existing context with the existing structure and the existing driveway added together with the proposed roof and the proposed driveway gives us a drawing. And that drawing is defined by the layer combination. So what can we take away from this exercise? Drawings, in other words, views, which are saved into the view map, are defined by a layer combination. So therefore layer combinations define a view as a particular type of drawing. So a floor plan layer combination is only used for floor plans. An electrical plan layer combination is only used for electrical plans. These two layer combinations will have some similarities, such as the external and internal walls. But in a floor plan, we will show specific elements such as loose furniture, like lounges and chairs. In an electrical plan, that information is irrelevant, so we wouldn't see that. Instead, we would be seeing the positions of lights, the wiring, the switches. So a layer combination is defined by the individual layers that are inside of it, like we've just explained. Layer combinations can be similar, but the individual layers we filter in and out are what defines the entire combination and therefore the drawing, such as that little analogy that we just used for the floor plan and the electrical plan. Or for a sun study diagram and a site plan. They both have similarities, but we remove the analysis component of one drawing and we add in the proposed design components, and they give us two different drawings and two different layer combinations. Now the best way to learn about layers and layer combinations is through a practical means, through doing. Before we finish up this recording and move on to the next exercise, what I'm going to do is I'm going to show you a screen which is a little bit intimidating. We're going to come down to the bottom here and we're going to click on this little stack of papers. And it's going to bring up the dialog window or the settings window for your layer combinations and your layers. Now this is a very practical and a very exposed way of looking at everything. If we click on one of the layer combinations and then we look at the individual layers section, we can see lots of little closed and open eyeballs. A closed eyeball represents a layer that is not shown. So this layer is irrelevant to an architectural floor plan. all of these eyeballs that are open are layers which are relevant to an architectural floor plan. So we can see all of the walls are turned on, because in a floor plan we should see walls. The slabs are turned on, because in a floor plan we should see slabs. Slab is flooring, ceiling, things like that. It's just a name for a tool. If we scroll up, we'll see the boundaries and setbacks is turned on because it's relevant to a floor plan. GN annotation, floor plan 1 to 100, is turned on because that is an annotation layer for the floor plan. Now, an annotation is a note. It's information that is relevant to something that we want to see in a plan. So we should expect to see floor plan annotations in a floor plan, but we're not going to see electrical annotations in a floor plan. Because a floor plan and an electrical plan are two different types of drawings and two different types of plans. See how the GN annotation floor plans is turned off, but electrical is turned on? That's because one is related to one and one is related to the other. They do not intermingle. But in an electrical plan, you can actually see that slabs and walls are turned on. So as we've explored, individual layers can belong to multiple layer combinations, but that doesn't mean that every layer has to belong to every combination. It's these individual layers that we turn on and off or filter in and out of combinations which defines the entire drawing. For instance, in a floor plan, we will see pretty much all of these that say extension M, so that's for models, so that's a three-dimensional element, turned on. In a site analysis, all of them are turned off because that is an analysis of the existing site. There are no modeled elements in a site analysis. You'll also see the floor plan annotation layer is turned off, but the site analysis layer individual layer is turned on. So remember, it's the filtering in and out of these key individual layers which defines the entire layer combination. And a layer combination defines a drawing, and generally we'll know what that drawing is that it defines based on the name of the combination. So a site plan uses a plan-site layer combination. A site analysis will use a plan-site analysis combination. A floor plan, whether it's ground floor plan, first, second, or a basement floor plan, will use the plan-architectural combination. Electrical will use the electrical. An elevation, which is a side view of the building, we use an elevation combination. A section, which is a cut through the building looking at the structure, we use a section layer combination. Each of these layer combinations will have similar layers turned on. But again, I'm going to reiterate this a lot during all of these videos. It's those individual layers that we filter in and out which define everything. Now we've come to the end of this exercise. What you now need to do is read this section and you'll see that exercise 1 is now complete. In order to start exercise 2, double click where it says exercise 2 part 1, the navigator. If you're unsure of where that is, have a look at this image here and double click it. It will bring you to your next exercise, but we're not going to start that just yet. We are going to end this recording here and we'll start back up next time. Thank you very much for listening, and I'll see you all next time.